I got a very unmissable thumbs up from the tech folks, so I think it's time. Is it time? You ready? Are you ready? Yeah. Good. Who here is sleepy? Okay. Everyone who's sleepy, you got to come to the front row. Let's talk a bit about C#. If you don't know me, I'm Matt Torgersen, and I am the lead designer of this programming language called C#. Have been for a while, not all the time though. And I got myself a problem because we released a new version of C# in November. And usually what happens, I sort of got into a little bit of a routine, is that whenever the build conference rolls around, that's when I start giving talks about what will be the next version of C#. Because we will have bits that I can show, and it's like just a good time. And then we ship it in November, and I'm like, I don't want to talk about something that we shipped. That's old hat. But here I am in February, and I hadn't thought about that. Like, so what do you talk about between when you actually have something to show and, or between when you ship something and you have something new to show? So I have nothing new to show. But I also don't want to just do slides all the time. So I'll just write code anyway. I hope that's okay. It also means that this is the first time that I'll be presenting on this, what's going into what we're thinking about for C# 13 and beyond. So I'll just be experimenting with how to present the ideas and so on. And some of it will work and some of it won't. And I'd actually love for you to tell me after if something was too confusing or it didn't work, because then I can do better next time. If you have questions, ask them along the way, and I'll try to notice, or otherwise shout, because there'll be so many different topics that we'll go into, and code that will exist only temporarily, like those quasi-particles that burst into existence all over the universe all the time. And by the time you ask a question, we can't go back and look at it or try things out. So I may run out of time, so then I'm gonna stop taking questions or something, but we'll see, right? So actually, you don't want to look at this web page here, but I don't have anything better to show you, so you'll have to look at it a little longer. Actually, we can, let's look at a different web page. So I want to kind of, when I wrote the abstract, I kind of got carried away a little, and I was like, let's talk about C#'s place in the universe forever. And so let me do that for a bit. Part of the story is C#'s been around for a long time. And if you really care a lot about that long time and how it changed over the years, come to my talk tomorrow. We'll look back and we'll look at all the ways that we stole and plundered from the functional programming paradigm and took things into C# in the past. That should be fun, but there'll be nothing new. How we think about C# though, has remained, in a sense, pretty constant. There's some things that have definitely changed. We started out being all about Windows. We were the Windows alternative or response to other things that didn't land so well on Windows, or Microsoft couldn't control them as much as we wanted to, or whatever. And since then, of course, hopefully most of you know, C# has become cross-platform. It's open source, and it's like most other programming languages now in that sense, right? You can just use it wherever you want for whatever you want. And we think of ourselves as aggressively multi-purpose. It's a language that gets used for many, many things we hadn't even imagined. Like so many games are written in C#, for instance. And that's all because someone else made a C# implementation many, many years ago, and people copied that and modified it and so on. And so C# went to places that we hadn't even imagined. And so as language designers, we feel a responsibility to remain true to all of that very varied usage. And part of it also, something that, so this grew pretty quickly or over time from C# being very, very specific to certain scenarios. One of the things we did from the very beginning, though, was compared to many of the other programming languages that we look like, or started out looking like. C#, if you think about levels of abstraction, like very high level languages, very sort of declarative, or very far from the metal to very close to the metal. Different languages kind of occupy different spans on that. And it's a simplification, of course, right? But one of the things that C# did from the beginning was to try to occupy a pretty broad span of abstraction levels, right? So you can be as abstract as any other object-oriented programming language, or in many cases now functional programming language, and at the same time, if I do this, can you see my belly? I get a little worried here. And at the same time, from the very beginning, it was important that C# reached quite far down and was able to do C interrupt and stuff like that, and was pretty efficient. Had things built in from the beginning that you could write pretty efficient code. So there was unsafe code from the beginning, but you could do pointer arithmetic and all that kind of stuff. We tried to move away from that now, but by replacing it with something that's as safe, but also as low level and as efficient. We had value types as well as object types. So, all these things where we thought about the low level and efficiency right from the start. We try to keep that as well, keep that broad level of abstraction view of the language. Not everyone will be occupying that full range in the way you code. Most people will probably be in the top half or something of the language. But because the bottom half exists, you have much more efficient frameworks, and you have games, and you have other things that rely on that lower half while staying within the same language. So that's kind of part of how we think of ourselves in the universe. And then there's just sort of the philosophy around what's the language for? What are we up to with C#? What is the purpose here? And that's kind of hard to quantify or put words to. But I think we've always leaned into C# should be delightful, right? You shouldn't have negative emotions when you use C#. It's bad for you. It's unhealthy. We should, for health reasons, health and safety, C# should be delightful, whatever that means. And so there's a range of negative emotions you shouldn't have. You shouldn't be annoyed. You shouldn't be frustrated. If you keep stubbing your toe on something, then you come and tell us, and we fix it in the next release, right? That's sort of how we think of it. You should, if you're surprised, you should mostly be pleasantly surprised. You shouldn't be confused. It shouldn't be hard to do things or hard to find out how to do things. You shouldn't be envious, right? You shouldn't wish you were in that other language. Essentially, in a nutshell, we want to keep, as long as we can, we want to keep C# a good choice for your next project. Right? So that's why we keep designing C#, because, of course, that's a moving target. It's compared to what happens in the industry at large. What are the other programming languages doing that is really cool and we can steal it and do it too? What new domains or new scenarios are happening? What are the big turns that we need to have a language level kind of reaction to, and try to keep up with that all the time. We have this is just the C# docs site. It's great for figuring out all kinds of things, including what's new in C# when there's something new. There's nothing in here yet about the next C#. But there also has, this is it's stodgy and weird maybe, but there's the C# language strategy, and that's sort of our attempt to have just one paragraph, a big paragraph of what is our mission statement, or what is our approach to C#? How do we make choices about C#? That's written in a way that's intended to be to be something we can stick to for decades. Although we do tinker with it here and there, right? So we want to evolve. We will innovate eagerly. So we given the choice, we will try to do something rather than back away from it. But try to stay within the spirit of the language. Try to make it not kind of flake apart. Try to make improvements that benefit most developers, either directly or indirectly, right? high commitment to backwards compatibility as well, so we don't break your code all the time. We'll come back to that later. And also, and this is something that's happened gradually and more recently, leaning into empowering the broader community to play a role, right? So we are now open source. The implementation of C#, the Roslyn compiler, is an open source project, and lots of people that don't work for Microsoft contribute to it, big and small, to the implementation of C#. And the language design itself has its own repo here that is also being contributed to, and this is where we work. Like the design process takes place in this repo. So, so we can get day-to-day interaction and feedback with people who use it, and other people who have great ideas who happen to not work for us, and so on. So that's something that we really lean into and continue to grow. Another way, of course, is for me to be here today. And so any thoughts you have, the way I get paid for a talk like this is the feedback that I get that I can take back home. So stop me in the hallway and tell me what you think about anything C#. Okay. All right, I think that's enough for the kind of general overview stuff. Unless you have questions in this regard, happy to answer. No? It's extremely calming that you are knitting in the front row. I'm like, Yeah, it helps me focus too that you're doing it, which is good because I can't knit to save my life. So. All right, let's go and talk about sort of more the immediate future then. So what I'm going to do now is to say, okay, so this is sort of the general landscape. We want to delight you. Okay, how will we delight you next time? And let's go, and I've got several Visual Studios open here. Let's do that one. And we can sort of reach back. I'm extremely happy that I didn't decide to do a C#12 talk, because I don't know how many of you were in Damien and Fowler's talk yesterday. They kind of went through half of C#12, all the good stuff. So I was like, whew, dodged a bullet there. Would have been a hard act to follow. But some of the things that we started on, or we niggle with in C#12, aren't done yet. And so we can start like quickly reviewing collection expressions is where I'm going to start, and kind of see where are the next places we could go from there. Okay, so we'll start with collection expressions, and we'll look at other things that are less there yet, and go crazy towards the end if we have time. Okay. So collection expressions. How many? Okay, let's get you activated. You probably had coffee and cake, and they're kind of warring in your belly right now. The cake's trying to put you to sleep. The coffee is losing the battle, keeping you awake. So I want to help. I want to be on coffee's side right now. How many people in here feel reasonably familiar with C# in some way, shape, or form? How many don't? Okay. Well, I guess I have I hope a friendly audience here. So how many people have used C#12 yet? Okay, C#11 or higher. You can keep your hands up if you're 12. 10 or higher. Don't know all these numbers. It confuses me every year. There's probably a lot of those as well. It happens to me. Like I used to be able to, I can't remember when we put what in, and frequently can't remember which version we're shipping right now. Collection expressions. They're like the runaway hit of C#12. Okay. A few other reasonably big things that I'm proud of, but collection expressions, man, that's a cool one, right? So problem, one of those things that you stub your toe on, and that's kind of a nuisance. Maybe you don't even realize it. It's just a drag on you in C# until recently is, okay, I'm using arrays. There's a certain way of creating an array from some elements. It's decently nice syntax. Oh, and somebody clever told me that I should probably, instead of creating an empty array, I should reuse the one that is available to me, and then I don't get less allocation. Great. Okay. But actually, I want to use a list of grade here instead. Well, of course, those ways of creating don't work for lists, but despair not. There's another way of doing that. You can just create a new list object and use collection initializers instead. And here there's not really anything to do, just make a new one. And okay, I'm good again. But now, okay, I've heard about these like span things. They're really cool. Oh, but I can't create them like that. I have to go and figure it out for each one of them. Go to documentation and look at examples. So collection expressions are a syntax for, that was weird. What? I have the latest, I just upgraded to, as you never should, to the latest internal build, and things work subtly different. So you'll see me do this weird thing again and again. See, look, never mind. Okay. It's actually a cool feature. I just need to do it to type differently now. So now I have this unified syntax for creating any collection in the world. How do I know that it's any collection in the world? I don't actually know. There'll be collections that I can't, but there won't be very many of them because we have like the compiler goes to town. It sees this, it's like, okay, what's the target type? Okay, it's span. Well, let me look at my list of different strategies for creating collections. There's a bunch of types I know about specifically. Span and read-only span are on that list, so I just know how to create one most efficiently. If I don't have it on that short list, then let me go and look if they have this new attribute that tells me that they can be created, and that attribute points to a method that will be the most efficient way of creating them, and then I'll call that, right? So anyone can plug into that using this new attribute, and then they can tell me what's the most efficient way of creating it, and the compiler would use that. Or, failing everything else, fall back to what collection initializers did before and just create it and call add with every element. And it'll know about, there's a bunch of like copy from and capacity, and it knows about a bunch of things that a bunch of collections has that it can try to use to do things more efficiently and avoid allocation and do things in bulk and all. So it'll just like do its best to write the most efficient way that you create this collection so that you will never sit there with the nice syntax and wish it was faster, because now this is in your tight loop and you have to go and replace it with something stupid and ugly and unmaintainable. So we really lean into making this the right choice, also for efficiency reasons, unlike maybe some features we did in the distant past. Okay? So that's great. What isn't so great is that, and I should mention one more thing. Of course, you can spread things in here. So if I'm not happy about my own grades, I can go and Michael is on the second row there. I know I went to his talk. I know he's super smart. So I'm just going to steal his grades as well and spread them in. And even though it's a different collection type, that's not a problem, right? It'll spread it in whichever most efficient way. But there's some things we didn't do. One thing you might ask yourself is, if I've got one of these, what's its like? I can clearly convert it to all these different collection types. What's its own type? Like, let's say that I grab it from here, put it into a temporary variable and pass that instead, var L equals that. What kind of thing is that? And there's no answer to that. We haven't decided what's the natural type of a collection expression. It's like lambdas. They didn't have a natural type for like a decade and a half, and then one day we're like, oh, this is what it should be, and then we added it to the language. Hopefully it doesn't take that long for this one. But there's like, it's a genuinely hard question. What should be the natural type of a collection expression? Because it could be sort of the minimal. It could be like read-only span or something super low level. And then you could make every use of it super efficient. But then if you wanted to add something to the end of it, well, you can't, right? Or it could be on the other end, it could be list. And that'll be super general, but then it won't be as efficient and people will fall into a pit of failure with their performance. So what's the right thing to do? And it's not just like the var situation there. It's what if I want to, let's say I want to for each var item in that thing, that'd be super cool to be able to do. That'd be a great syntax. And we could just do that without even deciding on what type it is. But it might be better if we do decide and it's sort of consistent. Another thing might be I wanted to, a good old-fashioned link query from G in that whole thing, where something. So what should we do here? What is the unifying theory of the type piece? We haven't decided yet. If you have thoughts. Anyone have thoughts? Make it a, so. Right, okay, so you mean like interpolated strings, just be magical? Right, but yeah, so the question is, which magic, like in a case like this, you can observe what the type is, like what, so we could possibly just do these other ones and just do whatever's best for those contexts. Yeah, we could analyze the whole context and see this is how it's used. So they're adding things, so let's make it list. Yeah, that's also a possibility. So it's a non-trivial question, and we were like, we can't figure this out this quick, so let's just not allow it. And that's what we did. So let me go back from that a little bit to something that compiles. It's always good to get back to a base where the red squiggles disappear, so we can introduce some new ones. Another thing that now that we have this whole theory of how do we create new collections of all kinds of types in C#, we can start using that in other places. For instance, params. Params span, that would be really cool, right? Because spans don't, if you don't know, then I'm telling you, spans don't necessarily, they can be allocated on the stack. And so params would not have to, if you do params of span instead of params array, would not have to allocate an array for all your things. They can just be passed on the stack, just like they would if they were real individual parameters. And so we could just allow params for any old collection, really. And that means whatever overload gets picked that has params, we would just take all those arguments and we would create whatever collection type was there, the same way we'd create it for a collection expression. It's almost as if you can just take away the brackets and the same thing happens when you have params. So that's pretty cool. So we're working on that one, and that's heading for C#13. That's like a low-hanging fruit once you've done the other thing. And it's going to be really, really useful. Like how many places in the current core libraries have like an overload with one argument, an overload with two arguments, an overload with three arguments, just because then for those cases you wouldn't have to allocate that bloody array, So you just get away from that now with params span. Or if you want another type, you want params list, just go ahead. Whatever you want, except it doesn't work yet. So that's another thing. And then the last thing I want to mention that could be next here is what about dictionaries? They're sort of like the smaller cousin, or bigger depending on how you measure, of the younger cousin, or I don't know, some kind of family member to collections. And with a little bit of ugliness, you can use collection initializers for dictionaries, for instance, and make that work. So it'd be kind of cool if we just kind of generalize that whole thing as well. And I think we're going to. There are some design decisions, but basically the syntax would be something. First of all, you need two unique key and let's say string to grade. You can say what the grade is in. Say something like geometry. Not sure about this syntax, but it's a key candidate. Spelling. Whatever. So that should be an easy fix. And the empty one happens to already work. Somehow that falls out from what collection initializers do. So we just need the one with elements in it. So that's kind of cool too, I think. I think that'd be useful next turn on the crank here. All right. So that's what I had to say about the next phase of collection expressions. Let's get back to something that compiles so I can screw things up again. Any questions, comments here? No? The cake is winning. The cake is winning. Oh, was the one down there? Shout it out and I'll repeat it. Will there be abstractions for numbers? So you don't have to decide what type of number it is. So we do have generics over numbers now. I don't know if you know about the I number interfaces and all of that. What's that?
We have the new generic type, but would that work with that as well? That it will detect everything automatically?
If what you mean is, could we sort of, could we do generic type inference through these list things to get the number types or something? I think so. I want to refrain from creating an example on the fly here, but I think that generally works out pretty well. Like we can infer, we tend to be able to infer the element type from the, I think we can infer the element type of collections from this. You make me want to try. Oh, I can't because this is a constructor. I'm not going to do it. It's going to take too long. But let's play with it after if you come up and remind me. Okay. Generally speaking, someone hand up. There, hand here. While he gets the microphone to you, generally speaking, type inference is one of the things that we are considering whether we can make that better without making it so good that results become very complicated and confusing. So, but I don't have anything to show on that. Yeah.
So what do you think, because like I think we already have something similar before, and in JavaScript, like hash table, it has the same kind of JSON structures when you initialize them, and in Python also the same. Why not we thinking about square bracket?
Why square brackets? Oh, that was such a big discussion. And I was like, the original proposal for this at square brackets are like, hell no. You know, collection initializers use curly braces. The other languages use curly braces. What are we doing here? Let's figure it out. Let's make it work with curly braces. And we tried, and we tried, and we tried. And there were so many ambiguities and things. This is one of those cases where you can really feel that the language is old and full of existing stuff. I can't remember all the details, but it became increasingly painful. This is way back, actually, before we even talked about collection expressions. This was back when we were doing the list patterns here. And so yeah, we just had problems making that work. And we were looking ahead to doing collection expressions and wanted to make sure that worked around. And we were just like, the square brackets, they just work nicely. And they remind me of arrays and that sort of collection here. Right? Don't they remind you of arrays? So curly braces, that's mostly like objects, and square brackets, that's mostly like collections. That's kind of what we lean into. And then once we had done the list patterns, a few releases ago, it was the obvious thing to have like the same delimiters for both when you're creating and when you're deconstructing collections. So that's how we ended there. And I know other languages do other things, but we don't have to copy them every time. We can be original. So, all right. I'll move on. I can't see any more hands, but apparently I can't see hands today. But come and ask me more questions after. We're like almost halfway into the talk, so I'll get a move on. So let me see. Let's talk about breaking things. Let's ease into it first. There's this tiny little useful feature that we've been wanting to do for a couple of releases, and we're now going to do it in C#13, I hope. I'm going to knock on some wood-adjacent material here. So there's this technical notion of a cliff, right? There's a cliff in the language. You're doing something, it's super elegant, simple, nice, and then you want to do just one little tweak, and you fall off the cliff, and you have to write like 5 lines of code instead. And every now and then, we try to eliminate some of those cliffs or reduce them, because that's one of those negative emotions we don't want you to feel, right? We want you to be happy, slightly, chilled maybe even. And so, so one of those things is, okay, I have an auto property here. Auto properties are really cool because, they generate their own setters and getters and backing field, and you don't have to do a thing. And we did add a few things to them over the years, like they can be getter only, they can have an initter, they can have initializers. It's cool, but hey, this name coming in, it's a string. I just want to trim the spaces off of it before I assign it into the backing field. That's all I want to do. And now, today I would have to like explode this into a full implementation of a property with a declared backing field and everything. But what I really just want to do is I want to just give the setter, I just want to write the body of the setter in a way where I can access the backing field that gets generated for me. And I just want to call that field, okay? So just assign, instead of, the default implementation does this, and I just want to say .trim here, right? That's all I want to do. So we want this to work. And that means field becomes a new sort of like contextual keyword or implicit parameter like value is today inside of properties. And it just says, hey, that's a backing field. It's, it just references the backing field. It's not actually called field. There's no field called field. It's called something else. But this is the way I can reference it inside of my accessors. And if I do rely on the presence of a backing field, either implicitly or by mentioning it, well, then it's an auto property. And if not, it's not. Okay, so now you can have auto properties and non-auto properties that are syntactically similar. But if you say field, then it's an auto property. That's cool. Gets me off the cliff. But it's also a breaking change. Unless we do contortions. And so let me talk about breaking changes and contortions. I'm not going to do live contortions on the stage. I'm just going to talk about them. I could do one or two if you're really sleepy, but it would get talked about. So why is it a breaking change? Breaking change means code means something today and it means something else tomorrow. Like bad, generally speaking, should try to avoid that because your code is busted. Negative emotions, don't go there. But the alternatives aren't great sometimes. And I'm going to talk about a few cases where the alternatives weren't great and how we might like approach a slightly more permissive policy around breaking changes. So here's something that's completely legal today. Like I have a researcher, for instance. He has a field of research. That's a property called field, and it has it has a backing field called field that he is, for some reason, he doesn't use underscores, or she doesn't use underscores, which I kind of forget sometimes as well. And so I'm referencing it in here. If that turns into, if this turns into like some sort of keyword or it starts referencing something else, well, now it's a breaking change. It's semantically different, maybe very subtly so, because this works exactly the same, except no one uses this field. Well, okay, that's okay. But then some other method thinks that it's sharing this backing field with the property, and they read and write from that, but we were actually now reading and writing from the generated one, and things turn weird. But we could also say something like, well, this means the generated backing field unless there's something in scope somewhere that already means field, and then it just means that instead. And that's not breaking, and that's kind of the approach we've taken in the past when we've been in this kind of situation. And it's okay, but it kind of just, over time, it really sucks. Because it gives you this spooky action at a distance vulnerability, where something gets declared somewhere, nowhere near your code, just in scope somewhere, and all of a sudden your code means something different. The classical example of that, like the first time we really did that, was var. So var, nice keyword, means infer my type here, except, somebody might have a type called var, and that would be breaking if referencing that didn't work anymore. So if I have a class here called var, now these turn into errors because these expressions can't convert to the type var. So the fact that I put that class somewhere just changed the meaning of my code very locally. And that's bad for the long term, right? So breaking change is ripping off the Band-Aid, and you're in a new world that's beautiful and nice. These solutions to avoid breaking changes, they just sit there and poison the language one by one, just a little bit, but enough that it just accumulates over the years and it never goes away. So time to look at fixing some of that. And so we're going to treat the field access feature there as kind of like a canary in the coal mine for trying out a new break and change strategy. And if it works well, then we can use it again on new features, or we can maybe even go back to some of the existing features that we did the sort of the easy but wrong thing with and revisit them and maybe change and maybe break them now. var isn't the worst one. The worst one is discard. So I'm not going to go into details, but underscore is a discard since C#7, except when it isn't. You know, this underscore here is a discard, unless, and if I declare a local variable in using certain syntaxes, that's called underscore, that's also a discard. But if I use the old existing style from before C#7 of declaring a local variable, then for breaking change reasons, that's actually a variable called underscore, and it's a real variable. And so now everything else that uses that underscore is now broken and no longer a discard because that thing is in scope. And so this is mentioned before it was declared. And if I moved it, it would have the wrong type maybe, or if not, and this would be a second declaration with a different type. And everything turns to shit. And that's wrong. Many people use discards, but they're frustrated because all of a sudden it doesn't work the way you expect. It's super confusing. So we want to ideally fix that as well. If this goes well, we'll come and look at discards again, fix them up, and make them just properly discards always. And if you had variables called underscore, we'll help you fix them. And that leads into how we're going to deal with these breaking changes. Okay, we're not going to do a lot of them, and we're trying to home in on a set of criteria for when we think it's okay to do a breaking change. Let me get that question first. Yeah, is there a reason why it couldn't be implicit? There are all kinds of proposals for, you could just have a different design of the language feature. And we looked at a lot of them. And at the end of the day, we felt like this was just the best design. And let's not have this slight chance of a breaking change ruin the design for everyone. So yes, there are many, many other ways that this could work. They're just not as pretty as this one, unless this one that we hadn't thought of. But we had thought of that one. So what we think, okay, one more question. What's bad about breaking changes? Because it's a compile time error and you can fix it. Well, it's not always a compile time error. The good breaking changes, like the friendly ones, are the ones that just hit you on the head, They whack you on the head and you can't get any further. They slam the door in your face because it's now an error. Great, I fix it. The sneaky ones are the ones like this one here, where it doesn't give you an error, it just changes the meaning of your code. And then sometime later in production, during tax season, you'll have a really nasty thing. So those are the ones that are really, and essentially sort of what I'm about to describe is turning those sneaky ones into the other kind in a way. And so what we propose to do is that as soon as you get, usually, there's a bit of time between when you get the new compiler for a new version of C# and when you actually start using the new version. In the vast majority of cases, the compiler gets given a language version. It's often inferred from your target framework or something like that. But the compiler gets told, compile this with C#12. And it keeps getting told that for a while, hopefully, after you get the compiler that's able to do C#13, until you choose to get a new target frame or to upgrade the target framework or explicitly say, go do C#13. So in the meantime, the new compiler is going to break your existing C#12 code by saying, hang on, this is going to change its semantics in C#13. Do you want to fix it now to something that will be robust against that change? And then we will offer a fully automatable fix, local and fully automatable, that you can apply here or everywhere, or you can choose to fix it some other way until those warnings go away. And then you're safe for a language upgrade. So we're going to get you before you upgrade. And probably we'll also implement a warning that you can turn on after you upgraded when you realize you hadn't, you did it anyway somehow, and now you have problems, you need to fix them. We can help you find them. But this is the main, and if you use an upgrader, then it'll just do the automatable fixes automatically everywhere to keep your semantics. And so that kind of leads to what are the criteria for when we think it's okay to do a breaking change. Question? That assumes that people jump from one version to the next. It doesn't really. Because if you're in C# 7 now, and then you get a compiler that's capable of C# 13, you'll still get those warnings. It'll warn all the way back to C# 1 if the breaking code was legal back then. So it retroactively makes it a warning for all existing language versions to do the code that now changes its meaning. So it actually avoids that problem. It has other problems, but it avoids that one. And so we think, okay, breaking changes, not a thing we should do all the time, but we should just be a little less afraid of them. We're pretty courageous in many ways. We should have a little more courage here too. If there are clear user benefits, if it's a clear best design, if we avoid some of those spooky action at a distance, kind of slow bleeding to death things, a candidate for breaking change. They should still be the kinds of breaks that even when they do occur, they don't like splatter all of your code, right? So yes, you will have a few fields called field if you're very unlucky. Like there'll be 3 classes or something in a whole like big thing that, okay, I have a field called field, it'll be broken. But they won't be like, we won't do things that are like, okay, now all of your code just turns to shit. So we'll try to assess that ahead of time as best we can. It should be easy to say that is where the break is and this is what's going to break about it. So it should be like diagnosable by an IDE or by the compiler and say, that's it, not some kind of like ephemeral thing. And finally, we should identify a specific default fix that always works and that requires no user interaction to apply, so that we can always say, fix them all for me in one fell swoop, and it'll do something that's non-obnoxious and local. Like for field, for instance, it could be, depending on the design we end up with, it could be that we turn this into this.field, or if field is just an or value is just an ordinary identifier in C#, even though we color it blue. So if it was like value, using the @ to make it an identifier wouldn't work because it's already an identifier. But we could choose to make field like more like a contextual keyword, and then putting @ in front of it would also be a good fix. So whichever one we settle on, that'll be the default fix. You can do other things, but that'll be the one that we will do automatically if you ask us to. Question? Can we have breaking changes? So settle on the 2-year cycle of LTS. It's a 2-year cycle, unless we changed it since I left for Australia. I think it's still 2 years. Perhaps we don't really. LTS doesn't mean that much to us. We were thinking we'll have just once a year where this ties into a bigger story with the CLI, the command line interface, and the .NET SDK, where there are other breaking changes that they want to do on existing projects elsewhere. It's nothing to do with the language. For instance, like block HTTP, that kind of thing. And so try to roll all of that into one experience that you can turn off if you're like, this is just my CI build, I don't want to get the... but so there's sort of like, we'll have a cadence of every year there can be a few new breaking changes across your whole project, and the language ones are one of those. They just plug into that infrastructure. So it's a bigger picture that I wasn't painting. But I don't think we will limit it to just LTS. People who only upgrade every 2 years, to only use the LTS cycle for upgrade, they will get the same number of breaking changes anyhow. Some of them will just have been out longer. So, okay. So that's breaking changes. We'll try it unless somebody stops us before we ship. And the field features, the canary in the coal mine, we can use it to refine the experience and tweak things. Or if it's like a disaster, we can say, never do that again, and then forget about this whole part of the talk. But that's that's some of that thinking that's not just about specific language features, but about how can we change our approach to the language a little bit to make the future better for everyone. Okay. Got 16 minutes left. I have 2 big features to talk about because I'm having a good time, and time is slipping from me. So let me try to see if we can get there. Okay. Let's go back here for a second. Let's again get rid of the squiggles. Let's talk about aliases. Okay, type defs, whatever you want to call them. We have using aliases in C#. They're not very cool. We made them a little better in C# 12. Now you can say, instead of saying system.decimal, you can just use the keyword now. But you still can't say decimal, right? Because usings can't see other usings. It's just so there. Okay, you can and you can now you can use. Oh, did I go into insert mode? That was terrifying. No, now I did. I rarely type in my day job, you know. Let's say that we want to use a tuple instead. String, comma, decimal. Okay, so now I can use tuple expressions. I can even give them names, string, topic, decimal, value. So great. However, I can't, for instance, make it generic and say, hey, it's a string and something else, where T implements I number of T. I can't do that because they're not types; they're just aliases. So in terms of what you can, so they're limited in what they can express. Also, they're limited in how broadly they can apply. If we let's get back to safe ground again. We now have global using, have had for a couple of releases, so you can reuse the using across your project. You can't export it because it's still not a type. There's no metadata. So I can't say like public using. It's just not a thing. So you quickly, if you want to use special names for special instantiations, or you just run up against the wall very quickly. So I want to start from that angle and talk about, and the name's going to sound weird to begin with, explicit extensions. And then we'll get to implicit extensions and why they're both kinds. So I'm going to do this in slides because the squiggles are just going to kill us. So here's another example of an alias that can do all the things that you can't currently do. And we use a slightly different syntax. We say explicit extension, then the name, and you type parameters for. So it's more like a type declaration. There's some things in here that can't be in an alias today. There's an accessibility that can be public. It's generics. You can talk about other types without having to say the full goddamn name of them. And also, it can have a body, whatever that means. Let's go and explore what that could mean. Okay, so it's a type declaration, but it's also like an alias for another type. And let's just call them extensions, because explicit should probably be implicit. And then if you want them to be implicit, that should be explicit. Not confusing at all. So I have a method here. I have a string. Hopefully, it's valid JSON inside, and if it is, then I'm going to display it. This one, I believe, is valid JSON. But I could have an alias, an extension for it called JSON string that signals the intent that this string should be one that contains JSON, and then I could use that alias instead. Okay, and that is public, so the consumer of the method somewhere else will also see the JSON string type name. It's not my little secret or in my library. It's a way that I can communicate with the world. This is a JSON string. But hey, when it's a JSON string, wouldn't it be nice if it had some extra function members? Like maybe I can parse it and get something back, like let's call it a data object, some like dictionary thing represents it. And since it has that parse method, then I can call it in here. When I use the JSON string name for strings, then I get that extra method on them that I can call. So I'm communicating extra things but it's the same type underneath, but I'm just giving you extra stuff I'm giving you a context to understand it within. And you could have multiple different extensions for string that represent different semantics for string, like an XML string. It's not very. You could also imagine like that data. Yeah, you have a dictionary thing. You could imagine putting a strongly typed face on like weakly typed data with this. So it's really all just data objects, or think JSON object or something like that, like some dictionary structure representing semi-structured data. But I'm giving it a face that is, this one is probably a customer. So why don't I give it some public strongly typed properties and methods to access it as if it was a customer. And sure, it'll blow up. It's like TypeScript typing. It'll blow up if I was wrong. But if I'm not, then I get IntelliSense and some type checking of my code and so on. And so as long as the assumptions I have about the shape of the data are right, then everyone's having an easier time. And you know, the blow up would have happened anyway. But in the meantime, I wrote nicely structured and compiled time check code. And you could have multiple of those, but they're all the same kind of thing underneath. Quick question. So the name property is there, and it has type string. The body of it is going to look up in the internal dictionary, and it's going to blow up somehow. So, so that's why it's going to be. So whatever data object gives you, whatever error it gives you, that's the error you get, right? You're just delegating to it and saying, hey, this just means look that thing up. And if it says I can't look that up, you know, exception, then that's the exception you get. Now. Let's talk about implicit extensions. So this is a trick. I'm doing a little trick here. So these are just like these thin wrapper types, and they're just interchangeable with the underlying types, but they give you an additional view on top of it. Well, if you declare them to be implicit, we could make it so that they automatically apply to the underlying type in scope of this declaration, whenever this is imported. So if I make the JSON object extension here implicit, that means the members here, it's as if they were really just declared on data object. They're extension methods. And so through this sneaky kind of backdoor, we've just made extension everything, right? Because now I can declare a thing that wraps any other thing with random function, as long as there's no new state, right? Random, they can be static state, but random function members, static, instance, indexers, operators, maybe constructors, whatever. Additional stuff. And I can just make it implicit, and then everything of type data object has that. So I'm saying right around here in this body of code where I've imported or declared this extension, data objects have a toJSON and a fromJSON. The toJSON is an instance, it's like an instance method. So it's like extension methods today, but the other one's a static one, right? So I can say, I can go to my data object in scope of this declaration and say, hey, I can say data object dot, and then call from JSON and get a data object back. So extension everything. Maybe in the distant future, they can even implement interfaces on behalf of the underlying types, but that's for another day. So. I'll take one quick question if there is one. Yeah, there. Sorry, you had your hand up as well? We might get both.
So I guess, what would be the advantage of using these, particularly explicit ones, over just like a class extension, class definition that extends? What would be the advantage of using these extensions over, say, like just use a class that extends the other object?
Well, if you use a class, you mean like in an inheritance sense, because this applies to existing object of that other type. Right. If you inherit, it'll feel like inheritance in that sense, right? You look names up on it, you'll look in that one first, and then you'll look up the chain. But you don't have to inherit that other class that you don't own, and somehow make sure that all objects get instantiated as your thing instead of that other thing, like all existing objects that get created elsewhere in your system. This is a way to just like existing objects of existing types, you can put on your special classes, and you can see extra things. It's sort of, it's like duck typing, but not quite. Hey, quick question there. So. Yeah, the point is it's a weird mix between inheritance and extension methods, and there was one more thing, and aliasing, right? And it is, but it's sort of like we've been cooking on this for a long time, and sort of like a unifying theory of how you can look at things you don't own, but give them your own kind of slant. And sometimes you want to do that explicitly, say for only some of those objects of the type you don't own, so per instance, per value. And sometimes you want to do it generally. You say, I just know more about these things. I just know that dictionaries can be converted to JSON. The guys who wrote the dictionaries didn't know that it was written before JSON was invented or something, right? Just didn't care about JSON. But I can add that enhanced view. And that way I can do layering and software composition and so on in new ways that give me more freedom. And the BCL are lining up to have various new frameworks kind of use this for layering as well. Like you can put things on some core type where they're discoverable, but they only show up when the domain that they're about is imported as well, or they only show up on certain generic instantiations of those types, or when certain constraints are met or something like that, and we can express all of that. So I think that's pretty cool, but it would work with steel classes because you're not inheriting, and you don't get like special access either, protected or anything. You won't get at that. Like you're looking that the extension is looking at it from the outside, just like anyone else. It doesn't get special privileges. It's all just like a magic trick to make it, make it show up and be nice. But I want to get to one more thing, and we're like 3 minutes out. So let's talk about unions. Okay. They're not going to be in C# 13 for sure. This thing might, but they are not going to be. But we've moved from a passive stance of, ooh, that is very confusing and there are many difficult questions. Let's not talk about them, like classic Strindberg family style, to actively talking about the challenges of union types, okay? Now, a lot of people say, I want unions in C#. And some people come from a functional background and they just love discriminated unions in functional languages like F# or whatever. And wouldn't it be cool if you had those in C#? Because they can do some things for you that, are nice. And some people come from like a TypeScript-like background. No, we want type unions. We want these anonymous things where you can just say int or string. And you can say that anywhere. And that just means it's either an int or a string. No declaration needed. It's just kind of like a... So those are seemingly very different. And why would you even actually want any of them? And so on. But people keep asking for it. So we're like, okay, what do you want? What are you expecting from this? And so on. We've been kind of following that down that rabbit hole. And just to quickly, and really have drawn no solid conclusions yet. But, to start at sort of like the functional style discriminated union, that is, when you look at a functional language, that is what they have instead of classes, okay? That and hierarchies. It's their core abstraction mechanism for when they want to describe a family of related types that have different shapes. So they have it. It's not like a yes and thing. It is their core abstraction mechanism. We already have classes, okay? So it's a big ass thing that it's a core thing. It's okay for it to be a big language feature. So I declare something like this, just made up some syntax. It's a union. It has some cases. And when you have a case, well, you can create a person to be of the case student. That means they have a shape of a student. And then, I can do pattern matching. We already stole pattern matching, so we're good here. So I can say, person switch. And then if it's a teacher, I can do one thing. But, because teacher is not a type, it's a case. It's just a tag. I have to immediately deconstruct it into the things it's made of. So I have to say teacher of var name, comma, var topic, and then I can return something like whatever string we can concoct of that. And I'm short of time, so I'm gonna fumble instead. And I could say student and do the same thing. And notice that I'm not saying person.student because typically these things come with like magic bringing the tags into the big scope for when you're pattern matching, maybe even for when you're creating. So you could just say this. And you see this is all working because I implemented this in C# yesterday. And I could do the same thing for student there, string name again. Okay, that's a little bit of a redundancy there, but that's fine. Int ID, maybe I don't care about the other one. Discards do work here, so whatever. And now if this was actually real, because there's a closed set of cases, this warning saying, hey, you haven't covered all the cases would go away and say, because the big thing that you get with this is exhaustiveness. Like you can have an exhaustive pattern match and you know you've dealt with all the cases. You don't need the or else thing at the bottom that, what should you do there really? So it'd be really cool if this worked, but obviously it doesn't. The only reason it works here is because I actually just declared some classes. You can see my backing. The thing running behind the scenes here is just that it's record classes, right? So they get deconstruction automatically and they're nested. So and I have a using static so that these things are. I'm just mucking this up to show you the experience. But when you think about it, I'm mucking it up with classes. But isn't it like actually, if we're trying to merge this into an object-oriented programming language, shouldn't these guys actually just be types? Why do I need to have a new thing called tags? And they can also be deconstructed just like classes already can and so on. And actually, when you think about it, if we have classes declared for these, couldn't we just do them as type unions, more like TypeScript style? Couldn't I just say, student or teacher, something like student or teacher? And maybe, that's a little bit too ambiguous and you have to put parens or something. Couldn't I have a syntax that just says, hey, this is a student or a teacher? And then somebody chose to have a teacher and a student class and to wrap the data in those, and they become, the name types, they become like tags. And that way you can sort of see like tag unions and type unions really are sort of the same thing. I don't need to specifically declare student and teacher as part of one specific family. I could just have them as generalized types, and I could let's actually have a mock type for them instead, so we don't get so many squiggles. I could add student or teacher or int, right? And they can be, and now the green thing would show up again here, and I would I don't know why I get a red squiggle, but out of time. Oh, the parens, yeah, the parens. There we go. And so I would just say, so now I would say, hey, you're missing int. So I could say, okay, if it's 5, do this. If it's any other int, I don't care which, do something else. And now again, it would be exhaustive and it wouldn't bother me anymore. So really these two are kind of related. And maybe instead of picking one and kind of closing the door on the other, we can find a way to embrace them both in a unified thing where cases are really types and tag unions are really type unions with named types. And I'll leave you there because we're a little over time. But that's kind of for further out in the future. But just to let you know, we're working on this and we're trying to think big thoughts and unifying thoughts to make this pleasant and not overwhelming in C#, to make it like a nice little add-on rather than, oh, this whole new functional programming thing that you have to choose up front. Am I going object-oriented? Am I going functional? I'm doomed forever to stay where I pick. So that's the latest, okay? Thank you.